Hi everyone, welcome to Java Techie. Previously, we understood Kafka PubSub mechanism using command line interface, right? So in this tutorial, we'll understand how to produce or publish a message to the Kafka topic using Spring Boot, and also we'll deep dive further to understand how the messages are getting distributed to multiple partitions. Okay, all right. So before I start the development, I am assuming that you guys already have gone through my previous Kafka videos. If not, I would strongly suggest you to check that, then come back to this concept. Otherwise, it will be difficult for you to sync with the Kafka components, which I will explain in this example. Okay, so without any further delay, let's get started. So let's quickly create a new project to demonstrate Kafka using Spring Boot. First, let me create a new project from the IntelliJ itself. Project, define the group ID, artifact ID, version, all the things. Change it to Maven. Let it be JDK17 is required since we are using the Spring Boot 3.0. Then specify this project name. Next, here you need to choose the correct dependency. So I am going to use the web dependency because I want to expose an endpoint. If I will trigger that endpoint, it will publish message to the Kafka. Okay, that is what I want to design. I need web, and the main dependency you need to add is Kafka dependency. Now if you observe here, there are two dependencies you are getting for Kafka. One is for Kafka stream, one is for Spring for Apache Kafka. Okay, so we are going to use this. Since we are not going to use the Kafka stream for now, we'll go with the Spring Kafka dependency. Okay, I believe that's enough. Now click on next. So next, once the project is imported successfully, since we are playing with the Kafka, first we need to start the Kafka server, and already I explained the order to start the Kafka. First you need to start the zookeeper, then you need to start the Kafka server, then as per your need, whether you want to create a topic and you want to configure partition count, replication factor, all these steps you can do. But to start the Kafka server, first you need to start the zookeeper. Okay, so what I will do, I will go to the directory where I install my Kafka. This is what the directory. Then I'll open the terminal. Okay, so I'll start the zookeeper first. So I already shared the GitHub link where I have defined all the command for the Kafka. So the first command to start the zookeeper, I will copy this. Then I'll go to the terminal. Fine. Then I will just start the zookeeper. Okay. Once I start the zookeeper, then immediately I will start my Kafka server. So for that, I will go to the terminal and I will take the command to start the Kafka server. Then I will open a new terminal. Okay, I can start the Kafka server here. Fine. So if you observe, my Kafka server is started on port 9092. That is the default port. Okay, I just highlight here. If you can see this, let me zoom this for you. 9092 is the default port of my Kafka server. Okay, and this is my zookeeper. Fine. Now all good. All our Kafka ecosystem is ready to start the development. Go to your IntelliJ IDEA, and first I will go to application.properties file, or you can create the application.yml file to tell to this application where is your Kafka server is up and running. If you will not specify that, how your application is know that where is your Kafka is running, so that you will publish the message, right? So that's the reason you need to specify in your application that where is your bootstrap server of Kafka Producer is running. Okay, so I'll create a file, I'll name it application.yml. Then I can define here. First I will define my server port. Let's say I just want to define something 9191. Then I will define Spring Kafka Producer, then bootstrap server. Okay, and give the URL. You can define multiple server port and host, but since we have only the default one, which is our local host, I will just specify here localhost and the default port is 9092. Fine. Next, let me create couple of packages where we can define our logic to publish the message to the Kafka. Okay. Next, let me create the service class where actually we'll write the code to publish the messages. So I will create a class called, let's say I will give a name something like Kafka message publisher, something like that. Okay. Now this is the class. So in this class, to publish a message to the Kafka or from our application, if you want to talk to the Kafka server, then you need to use some class given by the Spring framework, that is Kafka template. Okay, Kafka template. Define the key and value. For now, let me define the key as a string and value as a object. Let me annotate this class as a @service, and I need to auto add this. Fine. Now here I'll write a simple method public will simply return the message, nothing else. I mean, will simply return the message to the topic. So I'll name it send message to topic. What message you want to send? I will pass it from the controller. Since we have injected the template, now what we can do, using this template we can talk to the Kafka server. So I will just use this instance template dot send method. If you observe, send is the overloaded method. It contains multiple arguments. You can use as per your need. Since I just want to send a simple message to the topic, I will use this second method, overloaded method. I will specify the topic name. Let's say JT or Java Techie. Fine. And then I need to specify what data I want to send to the topic. This one. Now one thing you need to observe here, we have used this template.send method, but if you will take a look into its return type, it is completable feature. Okay, so this is the completable feature. So here if you want to block the sending thread and get the result about the sent messages, then what you can do, simply you can do feature dot get API call from the completable feature. Then the thread will wait for the results to come, but it will definitely slow down the producer. As you know, Kafka is a fast in processing platform. Therefore, it's better to handle the results asynchronously so that the subsequent message do not wait for the result of the previous messages. Okay. Now how we can do that? We can do this using a callback implementation. I'll show you that how we can do that. Let's remove this piece of code. We'll simply tell to this future object future when complete, when the future will be complete. Okay, then I will use the lambda. It will give me the result and also it will give me the parameter of exception. Okay, now I can simply print whatever the things I need. So just add a comma here and I will just add some print statement. Okay, so here what I am doing, I am just checking if x equal to null. If there is no exception, it means message is sent, and I just want to tag what messages we have sent and what is the offset number of it. Also, if you want, you can also get the partition number where the message went. Okay, so if you see here, there is a method result dot get record metadata dot get not record metadata. Okay, dot, you can see here the partition. Okay, you also, if you want to print the partition, you can do that, but let's make it simple. Okay, I am trying to make it asynchronous so that it won't wait for the result to come, and I am just simply printing the message. This is for success and this is for failure. Okay, that's it. Now this is the method who will send message to the topic. Now I will call this method from my controller class. So I will create a controller class quickly. I'll name it event. Now I need to annotate here at the REST controller. I'll also define request mapping and I'll give some URL here. Then I need to inject the Kafka message publisher, the service class. Okay, so I'll just inject private. Let me zoom this. So once we inject the publisher, now I can simply define the endpoint who will publish the message. Okay, so I'll write public response entity of type generic, let's say publish message. Okay, I'll pass the message in the request URL, annotated here are the path variable. Also I'll define this as a get mapping. Define the URL, I'll just define publish and what message I want to publish. Simple, right? Now what I can do, I'll simply call publisher dot send message to the topic and I will simply give the message name. That's it. But for safer side, I'll keep it inside the try catch. Fine. Now here I'll just return response entity dot OK and some messages. I'll give something like message. Similarly in the catch also I'll just define return response entity dot, I can specify the status which will be HTTP status dot internal server error or anything whatever you want to specify. Okay, then I'll simply build it. Fine. I have just handled the try catch here to just track the response or to just track the event whether it is successfully published or not. Fine. Let's say my Kafka server is down and I'm sending the messages, then definitely I will get the internal server error. You can handle it in better way, but this is the simple exception handling I have did here. Okay. So now we are all set to start the server. Okay, I mean application. Now if you observe one thing, we have not create topic manually. Okay, if you observe here, while sending the messages to using this Kafka template, I am just giving the topic name, but I have not created it manually through the command prompt. So whether the SpringBoot will create the topic for us or not, that we are going to verify. If SpringBoot will create the topic on behalf of us, then what is the default configuration he will add, that we are going to verify now. Okay, so all good. Let me go to the main class, just start the application. So you can observe here it started on port 9191. Now let's go to the postman and try to hit this particular endpoint /producer -app /publish on the messages. Okay, now let me clear this. Let's say I will just pass a message welcome. Can you see here message published successfully? And now if you'll go and check in your console, you can find that is what we have just added in our completable feature. When complete these messages we are going to print. The message we have sent is welcome. Let me zoom this for you. And the offset count is 0. Offset is nothing, the position of your message inside the partition. Okay, so that already I explained in the Kafka component and its architecture. So I hope that makes sense to understand this term. Okay, now I'll add some other messages. Let's say ABC, DEF, RAM, bemol. Okay, so I have published near to 4 or 5 messages. Now let's see. Go and check in your console. See, all the messages is assigning to the offset, but we are not sure whether it is going to which partition, because even we don't know the topic configuration created by SpringBoot. So let's verify the topic configuration. Then I will show you how you can create manually and how you can create programmatically. Okay, so now to describe the topic, what I can do, I will go to the terminal, then simply fire this command, give your topic name which is Java Techie -demo 1. So already all the required command I have shared in this Git repo. Okay, so I will also share this link in video description so you can use that. Now let me trigger this. So if you observe here, the partition count equal to 1 and replication factor equal to 1. So whenever we are allowing Spring Boot to create the topic on behalf of us, it will go with the default configuration with the partition count 1. It won't give you the correct or proper throughput. If your application is being used by multiple consumer, they cannot able to handle your request concurrently because of this partition count. Now how you can create topic with your own configuration. Let's say I want to go with partition count 5 or 10, 15 as per my needed. Then you need to create it manually. How you can create that? You can go to this, and I have already shared this command. Copy this and just go to the terminal again. Just trigger this command and you just need to change the topic name. So I will change it to Java Techie. Okay, let me create this. It created the topic for me. But before we use this Java Techie demo to topic, first let's verify Java Techie demo and topic, whatever the message we have sent, whether it is there in the topic or not. If it is there, what is the partition and what is the offset, we can visualize. Okay, so to visualize the Kafka ecosystem, I already explained you can use the offset explorer. Okay, just open this, then simply take the connection. Now if you'll observe here, there are two topics, right? Java Techie demo 1, Java Techie demo hyphen 2. Okay, so the first topic we use this demo 1. So if I'll open this topic, if I'll click on the data, and if I'll change it to the new, and if I'll send the request, we can see all the 5 messages we have published, right? Welcome ABC, DEF, RAM, Bimal. Okay, and corresponding offset, and all went to the partition 0 because we have only one partition. Now since we have created the other topic with the 3 partition 0 and 1, 2, you can see here. Now let's see how we can send multiple or bulk messages to the topic so that message will be distributed to multiple partition. So what we'll do, we'll use this topic in our code now rather than using the default topic created by Spring Boot to verify the messages, bulk messages is getting distributed to multiple partition. That is how the increasing the throughput from the middleman of Kafka. Okay, so what I'll do, I'll just go to the code. First I'll change the topic name Java Techie demo hyphen 2. This topic have 3 partition. Okay, so if I'll send bulk messages, let me write some logic to send some bulk messages. So I'll go to the controller. What I'll do, I'll just define a for loop here. Int I equal to 0, I less than equal to, let's say I just want to send 10,000 messages. Okay, that is how I can show you how I can send the bulk message. I plus plus. So here also I will just do some changes. With the message, I'll just append the number. Whatever the message I will send, let's say I send user, then user 1, 2, like 10,000 user string message will publish to the Kafka topic. Then we'll verify, since we have the 3 partition, how many messages is went to each partition and how the messages is getting distributed. Okay, this is the simple way to demonstrate this particular concept. All good. Let me restart it. So you can see here application started on port 9191. Go to the postman, then I will simply trigger here, let's say user, so that it will append user 1, 2, 3 like that. Okay, now I will send the request which will trigger 10,000 message to the Kafka topic. Send the request. It took 1915 millisecond. Okay, now go to the this particular offset explorer. Now let me refresh this. Okay, I'll go to this particular topic, and if I'll just verify the data, there are so many messages. Okay, now if I'll verify each message count from each partition, let's say I went to partition 0, it received 1682 messages. If you want to see the data of those particular thing, you can hit this, all the messages you will get from the partition 0, and you can find this offset here, right? So the count we want to see, it received 1682 out of 10,000. Now we'll verify partition 1, it received 51 5120. Now we'll see the partition 2. It received 3199. All the three partitions received the message from the producer what we just published now. Okay, so it clearly says that whenever you have multiple partitions, Kafka scheduler or zookeeper will take care to handle the message load and split it into the or distributed into the multiple partition based on their availability. Okay, so you can see here again partition 0, 1 and 2, they both have some information or some messages. So this is how Kafka distribute the load to multiple partition. Now the next thing, in a real time, do we need to create the topic from this command the way I have created here, Java Techie demo 2? It is up to you. In some case, in some industry, they have their own portal to create the topic from the automated way. But if you don't want to do, or if you don't want to create it from the command prompt, then there is a way given by the Spring framework. You can programmatically create the topic. Now I will show you how we can create the topic programmatically. Okay, just go to your code. So what I will do, I will create another package, config. Now I will create a class. Then simply annotate this @configuration. Fine. Then next there is a class given by Spring framework, that is new topic. Using that you can create a new topic. So let me do that. Public new topic. Make sure to import it from kafka.clients.admin. Now you can just return new topic. This is also overloaded method, and you can see here new topic, you can specify the topic name you want to create, you can specify the number of partition you want to use, and replication factor. See, all the required information you can specify here. Let me specify the name, Java Techie demo 3. Okay, and number of partition, let's say I just want to define 5, and replication factor, let's say I just want to define 1. So it will be in the sort, specify the count 1. Okay, let me zoom this. Now just define this @bin. Fine. So we are not creating the topic using the command, or we are not allowing our Spring Boot to create the default topic. Rather, we tell to the Spring whatever the topic configuration we need programmatically. We are telling him this is the topic name I want to create, and this is the number of partition I want to keep as part of my topic, and number of replication factor. Okay, now let me use the same topic in my services. Fine. Now let me rerun our app. So again it started. Now go to the Postman. Let me clear this. Now we have 5 topic. Okay, so we'll verify first whether the topic is created or not. Can you see here? Topic is created with 5 partition. See the partition count 0, 1, 2, 3, 4. We don't have any data because we have not published any message to this particular topic. Now same 10,000 messages again I want to publish to the topic Java Techie demo 3, and we have 5 partition now. Now let's see how many record is going to each partition. There could be possible that some partition will not get any single message also. Okay, because that is not in our hand, that will be handled by the Kafka scheduler, okay, or zookeeper. Now I'll just send the request. All the message is published. Let's verify it. Just refresh it. Go to the data, trigger it. Now let's see whether all the partition is getting the messages or not. Partition 0 received 3717. Partition 1 received 1954. Partition 2 received 496. Partition 3 didn't receive anything. Partition 4 received something, 3834. Out of 5 partition, partition 3 didn't receive any single message. Okay, so that is the reason it's not in our hand. It will be decided by zookeeper to whom he need to send the messages. Since we are only sending 10,000 messages, zookeeper assume that okay, this 4 partition is capable enough to handle those kind of messages to increase the throughput. Okay, so that is how they will decide. So this is how you can develop your producer application, and you can also customize your topic as per your required configuration to increase the application performance. Okay, so in my upcoming tutorial I will explain about the consumer part. So we understand producer and we send message to the topic, and topic is being splitted to the multiple partition, so all the message went to multiple partition. Okay, now in my next tutorial I will show you how you can develop the consumer and how concurrently you can handle the events coming from the Kafka topic to this consumer. Okay, do let me know in a comment section if you guys have any doubts. That's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.